to do a little trig review here because it's probably been a while since we've seen most of our trigonometry. And we're going to look at solving this equation and give a general formula for all solutions. So if you notice, they want a specific solution on the interval of 0 to 2 pi. So I'm going to take the cosine and I'm going to take this over here. So if we remember in trigonometry, for most values, we have two answers on the interval of 0 to 2 pi. So this is a positive 3 over square root of 3 over 2, which means I'm going to be in quadrant 1, but also that I could be in quadrant 3. So there will be two answers because if I had negative square root of 3 divided by negative 2, I would still get the same answer of positive here. So there are two intervals where I have an answer. Now, when they start talking about the general formula, that happens because if I take quadrant 1 and I add 360 degrees, I'm right back where I started. If I add another 360, so there are actually an infinite number of answers for this question when I start opening my interval up to different values, which is why it says by adding multiples of some integer k. So what I have to do is I have to essentially account for the specific answers between 0 and 2 pi, which would be in the entire circle, but I also have to account for the multiples of that answer. So when I go into my trig chart knowledge, I know that cosine is going to be the square root of 3 over 2 at pi over 6, or 30 degrees. To find that answer in quadrant 3, I would have to add 180 degrees, which would put me at 210 degrees. My pen is not cooperating today. And I could convert the 210 by radians, so I would get 7 pi over 6, I believe. So those are my two specific answers. So now I want to say this could be pi over 6 for a general solution plus k pi. And why is it k pi? Because if I add pi, that puts me here, which gives me my answer. And if I add 2 pi, it puts me right back here, which is also an answer. It's just a multiple of it because it's on a circle. If I add another pi, I'm back down here in quadrant 3. So it's the nature of the quadrant 1 and 3 answers is the reason why it would be k pi. Now, other problems may be k pi over 2. I may have to add intervals of pi over 2. I could add something with 2k pi. So you've got to really stop and think about the circle and go back to the coordinate plane to get a good idea of where you're working from with this when you're working with the trig functions, because we have to remember outside of that interval 0 to 2 pi, I have an infinite number of answers where I can take the cosine at that angle and get that square root of 3 over 2.